All right, so hello and welcome to Energy Wiz. I'm Sherry Shields, the Director of Communications at the FSEC Energy Research Center. Today's presenter is Mr. Danny Parker. Danny has spent more than 40 years in his career in energy efficiency research. He specializes in collecting and analyzing measured data from both residential and commercial buildings. He has a master's of science in environmental science, and he has several patents associated with innovative energy efficiency technologies. Most notable is his Gossamer Windward ceiling fan, which is available in Home Depot stores. So much of Mr. Parker's research over the last several years has been in highly efficient buildings and looking at the potential impacts when combined with renewable energy resources, which is what he will discuss today. So welcome, Danny.
Thank you, Sherry, and thanks everyone for your patience to be able to get things set up this morning so that they're operating properly. I'm happy to talk about this. Today's topic is how can you make a home in Florida more able to weather hurricanes, and at the same time to be able to provide you with year-round savings. None of us want hurricanes, but so if we're going to have them, how are we going to make it through and be okay? And then otherwise, can we find a way to do that where we live better throughout the year and we save energy too, we save money, and it's a good deal. And the title slide, I call it solar plus batteries equal big energy savings plus storm resilience, and that's true. All the things that are mentioned there are exactly the case, and we'll describe to you why that is the case and then why it's really the best option if you're considering something like a whole home power supply system for your house, which a lot of people are contemplating at this point. So we expect, as the temperatures warm around the globe, that since warmer air holds more moisture, more heat, the oceans become warmer, hurricanes won't necessarily become more numerous, but the modeling data suggests that they will be potentially more damaging. The ones that are damaging become more frequent because the hurricanes are stronger. And then the other thing is to tell you is that not only are the solutions that we'll discuss today, are they appropriate for having a home that's able to weather hurricanes, but it's also a home that's able to weather other types of power interruption, like earthquakes out in California or wildfires out in California that resulted in rotating brownouts or blackouts, or ice storms. And I had written this well before the problem that happened this last winter in Texas. Same thing. So all those situations, it's possible to have a home that's much more forgiving in terms of being able to make it through those types of issues. So it's not just hurricanes, but certainly hurricanes would be one of the applications where this would be helpful. So I live in a house that was built in Cocoa Beach in 1957 on a development called Loveridge for people at the Space Center. And we've modified it over time. I've been there since 1990. And on the roof, on the white metal roof, you see that we have solar hot water. The small panel that you see here is the DC pumping for the swimming pool, and then we have a 6 kilowatt PV system for the house. And then we've also done other things, some of them spendy, but others not. Some of the most important are we've installed all LED lighting, energy efficient appliances throughout. We have insulated the walls and ceilings pretty well. And the white metal roof turns out to be very important in Florida because The sun's heat, it's about 1,000 watts per square meter, and you can use that to generate electricity, heat hot water, or heat your attic. And so heat your attic doesn't help you in terms of comfort. So keeping the attic cool is a good thing. Keeping the PV systems cool is another good thing. So this is just to tell you that efficiency in terms of insulation or reflective surfaces or better windows, these things are all relevant and important for us to consider always. So up until 2017, that we had a power outage. Then we had Hurricane Irma, and what you're looking at here is on the left axis is kilowatt hours per day, and green is the amount of daily electricity I'm using at home. So you can see it's often 20 kilowatt hours, sometimes 30 kilowatt hours in the summer. But then you see Hurricane Irma, we had no power for most of a week, and you see our power use go to zero, and our PV output go to zero too, because of the a grid-connected PV system, a solar electric system, is turns off when there's no power, so that there's no danger to linemen and so forth. So, but that means also that you can't use it. So you're producing this amount of power, but you can't use it because there's no way of islanding it, of providing it only to the house. So this is frustrating. So you have all this PV electricity, solar electricity being produced, and that you see in orange here in terms of kilowatt hours per day coming from the roof, and you can't use it. And then everyone's trying to figure out how can you be cool when there's no power. And of course, in Florida, it's quite miserable post-hurricane. Everyone that's been through it knows all about it. And then we do find a way to keep going, and that's often generators where you're going out to buy fuel. You may find that there's not so many fuel containers, or that the pumps have run out of gas too. So there's all kinds of headaches, even with keeping refrigeration going during these times. So during that May, I installed at my house, I installed 2 Tesla Powerwall 2s. They are 13.5 kilowatt hours in capacity. 27 kilowatt hours can be provided from the 2 of them. So they were installed, and then this I'm not going to go into detail in terms of what the connections are all like, except that if you look at the left at this diagram, you can see that it's potentially quite complicated. And for a lot of homes, you may have only a certain number of things that you want backed up, critical loads. That would include things like refrigeration, or outlets that you're going to be using to charge computers, or certain things like that, and other things that you might not be able to service with the solar electric system, which would include something like electric resistance, hot water heating systems, or a clothes dryer, or unfortunately, a large unitary air conditioner. That may be something that would be beyond the scope of what you can easily handle. But I will be describing a solution to that that I have within my own house, so that it's possible to provide cooling with these systems. So everyone immediately wants to know what that costs. And so I might as well get that out of the way. So the cost each for the Powerwalls were $6,700 plus $1,100 for the gateway, the intelligent control that controls the way it communicates with the grid and disconnects or connects it. And the cost of the 2 Powerwalls turnkey that is operating was $18,100. And of that cost, about $3,000 to $4,000 came from the install. You could get a single Powerwall for a bit less, but it looks like to me that generally buying two is probably a better deal. And also looks like that they're making improvements in these, and so that the amount of storage you'll get from the new versions I've heard about recently will be even greater than what I was able to get 3 years ago. But here, another thing to consider is you could install a 6 kilowatt PV system at current prices at about $2 a watt, plus a Powerwall for about $21,000 after tax credit. And that will save $1,000 a year and reduce emissions. And in context, a whole house generator for a house is generally costs about $15,000 installed. And however, it saves nothing and it requires annual maintenance. You have to keep maintaining this, and if you're using diesel fuel, it only lasts about 2 years before it needs to be replaced overall. So in one case, you're spending about, for solar plus the storage, you're spending about $21,000, but you're saving $1,000 a year. The other one, you're spending $15,000, but you're spending money every year to keep it maintained. So what are the options? In Florida, we all face this. What are the options for dealing with power interruption? The most typical one is buy an inexpensive portable generator. And these can be purchased, of course, at outlet stores for $500 to $1,000, and they can provide up to 4,000 watts out, which is enough to run refrigerators, lights, and chargers. They generally use about 5 gallons of gas in about 24 hours, but they're noisy and they will use a lot of fuel. So you're using essentially a container of gasoline every day to operate them. There are slightly better models of those inverter generators, and those tend to be $1,000 to $2,000. They're portable, a bit more quiet. They use a little less fuel. But both the portable generators and the inverter generators both have the danger of you have to watch out for carbon monoxide accumulation wherever they're located. So a lot of people are looking at home standby generators, whole house generators, and they tend to cost about $7,000 to $15,000 installed, and they can use natural gas, propane, or diesel fuel to operate. They require a large tank if diesel is used, and they are expensive, and they do require maintenance, as I mentioned. So one of the things after I installed this was that I imagined it would be useful to test the Powerwalls in the wake of a storm that came close by us, we get a lot of tropical storms where the storm comes by and drenches us with rain. I was thinking, when that happens, then when it comes by and drenches us with rain, I'll shut down the connection to the grid and I'll see how the Powerwall gets us through that for the following week. Perhaps it's a case of being careful of what you wish for, because we actually, that September, we got a very close call with Hurricane Dorian, which was a really powerful, dangerous storm. And you can see here on the map how close it came to where I am, where we are here in Cocoa Beach. So it was beyond a good demonstration. It was quite frightening, frankly. So we prepared everything. We battened down the house and got ready so that we were ready to leave. My wife is here setting up things so that things won't blow away. She drives a Ford C-Max Energy, which has a 20-mile range with its electric battery, and I have a Tesla Model 3 that has approximately a 300-mile range, fully charged. So before the storm, we charged everything up, which is the way you should handle it with the storm. So chill down the refrigerators, top off the car so everything's fully charged. So this shows what happened on 3 September 2019 as the storm approached. And it was a close call. So, and there was, we were going to leave until almost the last minute when it looked like that the storm was going to veer off the coast, similar to how Hurricane Matthew had behaved several years before. So we decided to stay, and so we stayed through it. And this shows what the Powerwall system looks like operating. And you can see it's showing the amount of solar being produced at any particular moment, the amount going to grid or to the home or to the Powerwall or coming from the Powerwall. And then this shows that when the storm came, the Powerwall had 98% of its available electric power waiting to be used. So it was ready to go. And this shows as the storm approached, that the day when it was lots of squalls and rain, what happened in terms of the overall energy use. And this is blue is the power being used in the house in kilowatts. So you can see this is probably refrigeration, a lot of these square waves that you have here. And then the yellow is solar. And so even on a murky, rainy period where a hurricane's coming, you're still producing power. You're still producing, in this case, 13.4 kilowatt hours per day versus 21.7 used per day. And you can see us cooling the house down before the hurricane comes closer. So we actually chilled the house down, chilled down the refrigerators, and the Powerwall is topped off. We set it, you can set it into standby mode for storms. So it's expecting that there will be a problem. And then the hurricane actually passed by as was predicted. So you can see this shows at 4:30 a.m. That morning, the radar trace right off where we were, and then the satellite view of the same at the same time. And then what happened? So this is even that we did not lose power on this particular day, but I shut down power anyway. And these square waves are a refrigerator, but a lot of air conditioning going on here too. Power is shut down here when the storm passed by closest. And so you notice that immediately the green, which is the Powerwall, starts feeding, providing all of the loads that are being used, all of the electricity that's being used by the house. But then the sun comes up after the hurricane passes by. One of the things that happens with hurricanes is they draw a lot of moisture from the surrounding waters and land, and in their wake, they leave a soggy, sunny situation. It's not pleasant, but sun's still out. And you see that in the day, at noon, while the hurricane's bands are still coming through, we're producing about 1.7 kW, and we're producing more power than all the loads are that we're running at that day. In fact, so much so that you can see that this big, this is power being used. We're sending some power back to storage even the day after the hurricane passes. And then this big increase that you see here is one of the things that happens when you lose connection to the grid is you're only able to use power that you can use. You won't be able to do anything with, so it's useful to figure out what to do with it. So I actually charged the car up further during this time to try to use that power. And then at night, we're all running on batteries completely. And I mentioned that one of the things that I wanted to talk to you about were ways of setting up a cooling system to be able to operate. We use mini split heat pumps, which I'm a big advocate of now. rather than central air conditioning. They allow you to cool particular rooms in the house to whatever temperature you want. We have a central one that's located that serves as essentially a backup. And if we shut down those in the other rooms and then let the central one run flat out during the hurricane, and you can see that we're able to maintain reasonable temperatures during this time. This is with the Powerwall running everything for the week after. So we're not using grid power, and basically the temperatures were less than 80 degrees inside, and relative humidity going down because we're running that central little mini split heat pump pretty strongly. So I'm a big advocate of them, because also too, another thing that happens from using them is if you use them with the central system, as FSEC research has shown, you'll save money over the year, and you end up with a redundant cooling system. So if you have a central system, you add that in addition to it, and that way you have a backup that's easy to run post-storm, so that you can not have any issue running down the storage that you have in the batteries, and also provide 24-hour cooling for your home, which is, after a hurricane, is really a huge deal. So this shows the next day, the hurricane's passed. At night, the Powerwall is running everything. And during the morning, the sun comes up, and then we're producing more than we're using again, and we're charging the storage back. So what we used at night, we're putting back in the batteries. And then we start looking to try to send that to grid. So I tried to, again, find things to do, time to do some laundry, do the wash, charge the cars or use them. So basically you find a way. So we had power to burn after, and we did this for a week, so that we're not only, and so you see that we're able to essentially provide all the power use from the batteries and carry on with normal life. No change in anything, really. Everything just the same. That's what you would normally do. And as I mentioned, you find a way to use this excess power that you have, run the other air conditioner that you haven't been running, chill the house down further, do more laundry, run the dishwasher. So when you got it, and you can see this on the app that comes with the Powerwall, so you can see exactly what's being used. And I'm going to show at the end of the presentation here, I'm going to show that in real time, so you can see exactly what's going on right now with the system, and you can access that anywhere in the world, it turns out. So disaster, if you have disaster either from hurricanes or earthquake or some other event, like even in winter, solar PV plus batteries work. The cost of adding the storage is $11,000 to $18,000, depending on how much you're adding. The cost of a whole house backup propane system, $5,000 to $15,000. The key to making the solar and battery system work well is home efficiency. And with low power mini split heat pumps, you can cool the entire house. To make that work best, a really important thing is to minimize the nighttime loads on the batteries. And so efficient lighting and appliances are important. And if you have an all electric house, it's important that I mention to you that heat pump water heaters are a really good deal and really great technology for Florida, because a conventional electric resistance water heater draws about 4,500 watts to operate the resistance elements, whereas a heat pump water heater, it's only about 400 watts, so a factor of 10 lower in terms of power demand. And then there are other things that you can do, the things that most people think of, which are like good windows and better insulation and so forth. And I do mention that I bring this up just to tell you I don't have a solution, but I want to bring it up, which is there are equity issues associated with this. So if you look at the solutions that are being used either for solar PV plus batteries or whole house generators, these things are being done by people that have financial resources, but a lot of people don't have financial resources. So this shows that on the left, after a hurricane, a family of 5, no power, no generator, someone asking for help. And then the fact is that low-income households, they spend a lot of their money on electricity, whereas the amount for average Americans is only about 3%. So disaster affects everybody. And so how do we make it so that it's easier for everyone to afford something like solar plus storage? So that is possible, even though someone would say, well, $20,000 is a lot of money. Yeah, it is a lot of money. But, most of us, almost all of us virtually do this, spend that amount of money for something. And it's called an automobile. And that automobile is considered to be required for daily life in modern society. But it's something we all buy, and we all can obtain financing for it. And we also buy it, and it goes down in value constantly, and it requires money to keep it going. So unlike a solar system plus batteries, which is actually going to save you money year round. The problem is that utilities don't have a disincentive to help with that, because they're interested in having us pay them so that their investors are doing better. But I work for the people of Florida, and I believe that it would be useful for utilities or for others to provide subsidy to try to help all of us, similar to the way people can afford to buy cars on time. We could be able to buy solar systems and battery systems on time too. So that would be useful. So how do these options compare? I've already mentioned the overall cost of that, and I just summarized that here on the right. The portable, inexpensive generators, the inverter, and the home standby ones. And then I've got this detailed spreadsheet that I'm not going to go over in detail, but it basically is to show you that if you're looking for the best option, the 20 kilowatt whole house generator is a more expensive option if you're looking at what the total cost is over 15 years. Then the PV system, solar PV system with storage is actually the cheaper option because you're earning money over the year using it. So it's actually cheaper. And then this is the final one here is that system plus storage with a mini split heat pump. If you have to have that to add cooling, it's still about the same. So you're able to add a redundant cooling system, batteries, as well as solar PV, and then end up with something that is cheaper than a whole house generator. So my final slide is conclusions. What's next? Well, storage costs will continue to fall, or the technology will continue to improve. And we've seen more of this latter. That is, I actually think that the cost of power walls maybe have gone up slightly, but the install costs tend to be high, and that's kind of an incompressible cost at $3,000 to $4,000 to install. And if you look at the lower image I've got here, you can see why, which is you end up with, especially if you have a critical loads panel, a backup panel, you end up with a pretty complicated bit of work for an electrician. And so I have one size fits one, which is each house is going to require specific circumstances. There are other things that enter into this and could potentially enter in a big way. One of the ones that I'm a big advocate of, it would be very useful to have emergency use of the car battery that you have. With the current initiatives, many of us in the future will be driving electric cars with big battery in it, often 75 kilowatt hours or more. And that battery in an emergency could be used to power your house rather than having to have a completely separate battery system for the house. Or it might be possible to have the gateway plus a small battery that can be augmented by the car battery. To me, this kind of makes the most sense because you're still going to have a way of managing the loads with, even if you're using the car battery. So the gateway that's augmented by a car battery would seem like that would be a very useful direction for technology development. And then we need utility programs or government-sponsored programs to add to deal with the equity issues that were brought up here and to make it so that the average person, the average household can afford to install solar, put in batteries, and do these things so that they're more resilient after disasters. They're not so desperate as we saw with the person where they were describing that they had a large household with no power, no generator. So that's what I have for my presentation. This shows, you can see exactly what's going on at any particular time with this. And I just changed it to self-powered. Probably we're going to see nothing change because the house is producing more power. I mean, the PV solar, there it goes. It looks like it's doing a little charging of the battery system. It just changed. So you can do this anywhere. And so it's possible and you can manage the system remotely just from your phone so that you can make it so that you can change the way this is set up. This is useful in particular for places or that don't have net metering, so that with net metering, you essentially are using the grid like a bank. You can, whatever power you generate, the excess, you can save that, and it's going to be used and credited to you so that you can use it at a later time. But if a utility isn't providing that, then it's possible to set yourself up within that app so you're self-powered, so you're using the grid as little as possible. And this is a way of getting around, or certainly using the battery storage as a way of addressing some kind of limitation that's imposed like that. So I guess at this point, probably it's useful to take questions from anyone that has something that they would like to ask.
Yep, so if anybody has any questions, you can type them into the chat.
I guess, number one would be, what did I not tell you that you needed to know?
It was a lot of really good information, Danny.
So, usually people are saying like, well, let's see, can I anticipate some questions? Can you find systems like this that are not necessarily Tesla systems? Yes, of course you can. For instance, Sonnen makes a battery storage system, German company, but there are others, and it depends. Battery technology that you're using is an important fact, and not only in the cost, but then also in the maintenance. And some people in the audience probably know a lot about that. Batteries are notorious in terms of being difficult to maintain over a long time. But all I can report at this point is with the system that I have myself, I try to exercise it, that is, make sure everything's operating properly about every 4 to 6 months. And we just did. And I've seen no problems in 3 years. In 3 years, it's a small amount of time, but I've seen no bigger issues in that. Will we see the price of battery storage come down the way solar electric systems have come down? I really doubt that, because like I mentioned, there's this cost that's largely incompressible associated with installation. And while storage may become cheaper, I don't think we're going to see that same level. That doesn't mean that it's not highly desirable, however. So,
Danny, so we have a question. Have you seen any advancement in solar shingles coming to market?
Actually, to be honest with you, and I'll be honest with you, I'm not a fan of solar shingles for 2 reasons. Reason number one is, I'm aged myself in mentioning this, but when I was a kid, people wanted hi-fi, which is, then later becomes stereo. But, in hi-fi, it was often like in it. And then vendors started providing hi-fi, which was a phonograph, so that it was integrated with a radio, for you as well, and then eventually a tape machine, or tape player, a cassette or something like that. And so you had a record player, radio, and cassette all in one. And then when any one of those had trouble, you were done with the others, because they were integrated, they were all together. And so if you had trouble with it, then you're going to lose everything. Whereas, and at least in the stereo world, separates became more popular, because if you had trouble with one, you just had trouble with one. Just replace that one. Same thing with a roof. Roof is really important, primarily to keep rain off your head. So if you have trouble with the roof from leaks, then you're going to lose the PV. If you have trouble with the PV, you're going to have trouble with leaks or difficulty in terms of scheduling. That's number one, which is, I don't like things where multiple technologies that have various failure tendencies are all together. I realize it looks good. That's nice. I'm happy about that. But it has that problem. The other problem it has is all PV systems get quite hot when operating. That is, they absorb solar radiation. They convert some of it to electricity, and then the rest is released as heat. And so the panels become very hot. As I mentioned, in Florida, it's important to keep the attic cool. If you have a central cooling system, which most of you do that live here, you have ducts that are up in the attic, tend to be insulated to R4 to R5, maybe 6. Anyway, that's nothing, because you're feeding 50-degree air through them, and you're losing on a hot day, you're losing about 1/3 of the cooling before it even gets to the registers, because the attic is hot. So you want to keep the attic cool. The best way of doing that is having a roof that actually that reflects the radiation away, so that the attic is cool. Or the other best solution is don't have ducts up there. Use mini split heat pumps that don't use air distribution systems. They have cooling, direct refrigerant to interior cooling systems in each space. They don't have that problem. So anyway, long answer to your question. But yeah, I know they're working on them. I know they're always more expensive. And I know that my expectation is they'll have more trouble with them going into the future than they will with standoff arrays, which actually shade the roof in the segment where they're located. So if you have 1/3 of the roof is covered in solar electric PV panels, you have a third of the roof that's not being heated by the sun too. So
Good point. So Danny, how long do you expect those Tesla Powerwalls to last? What's the lifetime on them?
I think the warranty is 10 years, so 10 years.
Okay.
I don't know. So, the people that know me here at FSEC know that, I like to try things that are new. And if you try things that are new, and, I do that because the only way to really learn how something works is to have some personal experience with it, or at least that's my feeling about it. So, so sometimes people talk about the cutting edge of technology. So, that's advancing yourself to the bleeding edge. So, you basically try things that don't work. So, and there's other things I've tried that have not worked well. This is one that has worked well. So if you try new things, you will have, some experiences that are not exactly what you anticipated. For instance, with the mini split heat pumps, I can tell you that I've learned that to the extent that you can avoid them, always avoid condensate pumps. Okay. Condensate pumps, you want to be able to send the condensate through an exterior wall, just have it weep from the system. But having it accumulated by a condensate pump, they're incredibly noisy. No one's going to like that. So, and then they're prone to failure too. So don't do it. So anyway, that's the other advantage is working with new things is you get to warn people about the potholes you found.
Right.
Anything else?
Yeah, I'm saying somebody mentioned about better solar panel materials, and so yes, as those comes out, we'll experiment with those.
Yeah, of course. That's something that both energy storage, that is the batteries, as well as PV panels, they're just getting better all the time. Both. So PV panels are getting cheaper and they're working better and the efficiencies are higher. And I don't see that stopping. So, I think 20% efficiency will soon be considered kind of normal. Whereas a few years ago, we were talking about, wow, it's amazing that can be achieved in the laboratory. But, we're able to do ever better with that.
All right. Well, I don't see any more questions. So thank you, Danny. I appreciate all the
Thank you so
information.
much for your tolerating my problems with getting this all set up.
It's all good. It's all good. Thanks so much.
Thank you. Thank you, everyone. Good luck.
Thank you. Bye-bye.